to do a quick recap of what we did on Monday. And what we did on Monday is we were looking at equivalent lengths, and we were looking at millimeters, centimeters, meters, and kilometers. Now, remember, guys, if I'm going from kilometers to meters, what do I do? Do I multiply or do I divide, and by how much? Tell me in the chat. I know it looks very obvious because I've put it on the screen for you. So just let me know. If I'm going from kilometers to meters, what do? I multiply by. Styla, it is right on the screen. It's not a trick question, it's on the screen. Good. I multiply by 1,000. Okay, and if I am going from centimeters to millimeters, what am I doing and by how much? It will not be multiply. Have a look. I'm going from millimeters. Did I say millimeters? Yes, I did. I'm going from millimeters to centimeters. What does my rule say I need to do? Good. I need to divide by 10. All right. So that's what we're going to be doing. If you do not have this somewhere near you, you are going to need it. So I would suggest you take a screenshot right now before we get started, because you're going to need it for the exercise that we're going to do. Okay. Everybody's got 5 minutes, 5 seconds. 4, 3, 2, and 1. All right, we're going to start the exercise. No problem, no crazy. Welcome. All right, you guys have 3 minutes to answer these 3 questions. Okay, I'm going to see if I can fit everything on the screen at the same time. Okay, let me see if I can't move this up a little bit. And maybe you guys will be able to see the rules as well as the questions at the same time. Let's see. Aha, I managed it. There we go. Okay, awesome. All right, 3 minutes, guys. When you're done, pop the word done in the chat, not chat in the done, done in the chat. Okay. Thank you, Emerson. Emerson, if you put your hand up, you can do the first one. Okay, that's fine, but I am going to need you to unmute for me when I ask you to. Jiria, I don't want you to get used to doing a specific question. I want to see if you can do any question, because if you can do any question, that shows that you actually know how to do the rule. So is it okay if I pick the question for you? No problem, Liam, welcome. Okay. Anybody else who'd like to answer one of these questions? I want you to put your hand up for me, please. Excellent, Italo. Hello. All right, and that's time. Jiria, I'm going to ask you to do number 8. Oh, no, Emerson. I need Emerson to do 8A for me, please. Emerson, hello. Hi, Emerson. Can you unmute for me, my sweetie?
Hello, ma'am.
Hello, how are you?
Great, ma'am, and you?
Good, thank you. All right, Emerson, so I'm going from millimeters to centimeters. So what do I need to do?
Ma'am, you divide by 10.
Excellent, I'm going to divide by 10. So what is 28 divided by 10, Emerson?
I got 2,8 centimeters.
Centimeters, excellent, well done, amazing stuff.
Thank you.
Awesome, excellent. All right, who do I have next? Jaria, let's do 8B together.
Hi, ma'am.
Hello, how have you been?
Good.
I'm glad to hear it. It's awesome to have you back. Can you do 8B for me? I'm going from millimeters to centimeters. What am I going to do?
Okay, so we're gonna say 8B is 4,9 centimeters. We're dividing
Good.
by
How did you get to 4,9?
we divided
49
49 by 10.
Excellent, which gave us 4,9. Well done, Jiria.
Thank you.
I'm glad you haven't lost that touch since you've been away a while. Okay, Master Chava, let's do 9A, my sweetie.
Okay, ma'am.
I'm going from centimeters to millimeters. What am I doing?
You multiply by 10.
Excellent, I'm times by 10. What is 4,3 times 10?
It's 43 millimeter.
Millimeters. Well done. Well done.
Thank you, ma'am.
Maria? Maria, let's do the next one.
Hi, ma'am.
Hello, how are you?
I'm good, and you?
I'm great, thank you. All right, I'm going from millimeters to centimeters. What do I need to do?
I divide 682 millimeters by 10.
Excellent. And how much will that give me?
68.2 centimeters.
Excellent. All right, well done. All right, Liabona, let's do the next one together. I'm going from centimeters to millimeters, my sweetie. What am I going to do? Hi, Liabona. Oh, Liabona's not unmuting. Oh, there we go. Hello, Liabona.
Hello, ma'am. How are you?
I'm good, thank you. How are you?
I'm fine, ma'am.
All right, so I'm going from centimeters to millimeters. What am I going to have to do, Liabona?
Divide by, I think, 100.
Oh, have a look at our board first. Have a look up top here at our board. I'm going from centimeters to millimeters. What do I need to do? What does my rule here say?
Times 10, ma'am.
Times by 10. Good. We're going to multiply by 10. So I'm going to take 44,14, and I'm going to multiply by 10. And how much is that going to give me? Anybody can help him out in the chat?
Gonna give you
Landile's helped you out in the chat. He says, have a look.
441.4, ma'am.
Good. 441,4 millimeters. Excellent try, Liabona. Okay. You need to learn that rule there at the top. It's very important. Okay.
Okay, ma'am.
Thank you. I need you to mute for me, please, my sweetie. Lingomso, let's do the last one here.
Yes, ma'am.
I'm going from millimeters to centimeters. What do I need to do?
So, divided by 10.
Good. I'm dividing by 10. What is 80 divided by 10, my sweetie?
80 divided by 10 is 8.
8 what?
Centimeters.
Excellent.
Centimeters.
8 centimeters. Very, very well done, Lingomso. All right. Okay. I'm glad everybody's familiar with the rules. Guys, if you're not, I'm going to give you 5 more seconds. Here we go. Take a screenshot of this here at the top because you're going to need it again. Okay. As we're going through and we're learning about shapes and mainly 3D shapes, we're going to be looking at this. Okay. All right. Okay. So today we're going to be learning something new. We're going to be looking at unpacking shapes. And this is not the shape I wanted to show you guys. This is the shape I wanted to show you guys first. Now, this looks like a box. I wonder what kind of box we would say this was. What do you guys think? What would go inside this box? What would go inside a box like this? Teacher Kat, do you have any idea? Let's think.
Oh, that's a nice one, Randile. Laptop. Randile
A
said
laptop. Okay, cool. All right. So we can call this a laptop box, right? A laptop box. Now, this is not a 2D shape, guys. It's not a 2D shape. What kind of shape is this? You guys know? What kind of shape do we call this? Good, Khatiso. Excellent. It's not 2D, it's 3D. Good, because 2D is like when I draw on a piece of paper. If I draw something on a piece of paper, that is 2D. But 3D, why do we call it 3D, guys? What makes it different? Keisha says volume. Okay. What about volume? Like, is it when I start speaking and I get louder because I've turned up the volume? Is that what we're talking about, volume? Good. Silas says it's 3-dimensional. You guys are on the right track. But guys, if we think about it, what does 3-dimensional actually mean? It's like, it has sides. Yes, my sweetie, yes, it does have sides. Okay. Landile, you can say that. It has 3 sides. Okay. It's not exactly 3 sides. Okay, Jaria, you're onto something, but what you've given me is not area, and area and volume are not the same thing. Okay, now guys, something like that, Jaria, we're going to get to it at the latest. Okay, we can see all the sides. I like that. We can see all the sides. There is more than just one side to see, guys. So when I draw a 2D shape, how many sides of my shape am I seeing? How many shapes or how many sides of my shape am I seeing here? Bokang says 4. Good. There are 4. There are 4 sides. 1, 2, 3, 4 sides to my shape. Now let's look at this 3D shape that we've got over here. Right? I can see 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you look at the back, 10, 11, 12, there's going to be like back here, like that. If I do that, there's going to be another side over there, another side over there, and another side over there. Okay, so there are many more sides to be seen. And basically a 3D shape is something that you can hold in your hand. If I think of a 2D shape that I've drawn, guys, can I hold a 2D shape in my hand? Am I able to hold a 2D shape? No, not really. Okay, a 2D shape can't actually lift off a page. But because this is a laptop box, can I hold a 3D laptop box in my hand? Am I able to do that? Absolutely. Absolutely. Of course I can. I can hold that in my hand. But now we're not exactly going to be looking at volume today. And I know when we talk about 3D shapes, we normally talk about volume. Before we get to volume, we're going to be looking at something called surface area. Has anybody ever heard of surface area? I'll give you guys a hint. It has something to do with area. Keisha, what have you heard? Do you mind putting up your hand and I want you to tell me, what have you heard of surface area? Good, definitely about surfaces, that's for sure. Tanweer's onto something. Tanweer says, it's the area of the surface. Well, Tanweer, technically you're correct, but which surface? That's a good question. That's the the question we're getting at here? Okay, Keisha, if you're not sure, you're too shy to unmute, it's okay. All right. So here's the thing, guys. Good. Nokwezi, 100%. 100%. Nokwezi has the right idea. When we talk about surface area, we're looking at the 3D faces. The surface area is the area of the 3D faces or the 3D surfaces of my 3D shape. Now, if I asked you guys, if I drew a square and I asked you guys to draw or to find me the area, if this side is 4 centimeters, you're going to be able to find me the area. You're just going to say area is equal to length times breadth, which is the same as 4 times 4. And my area will be 16 centimeters squared. The area is easy enough. But if I think about having a 3D shape, guys, I don't have just one side. Good. Liam, excellent. It's the measurement of the total area, the whole area. Now, if we look at my 3D shape, I have over here, I have a rectangle up top here. And then I have another tiny rectangle over here. And I have another one over here. And I have another one at the bottom and another one on the back side over there. And I have another one on this side over here. Do you see? So when I ask you for the area, which side are you going to calculate? We can't exactly calculate the area of one of these. We have to calculate the area of all of them. Good, Della, we're calculating the area of all of them. So when we look at the surface area, we're counting how many surfaces we have that make up our 3D shape. So I've got this side over here, this side over here, and this side over here. Are those the only sides that I have, guys? Just 3 sides? No. How many sides do I actually have? Good. Ooh, Bokang says 4. And if it's tripping you up a little bit, I want everyone to grab a book because a book is 3D. I've got a nice book over here. It's called Pachinko. Always wanted to read this book. If I go and I hold a book, you can count how many sides a book actually has. 1, 2, 3, 4, 5, and 6. It's 6. And Randile is like, bruh, it's 6. Yeah, bruh, you're correct. It is. It's 6. Okay, it's 6 sides. But do all of these 6 sides have the same area? Do they all have the same area, guys? No, they're not going to have the same area. If I look at them in this drawing that I've done over here, I've actually unpacked the box for you. So I've taken it and I have unpacked it. And when I unpack it, I can see that this side over here is the same as this side over here. And these 2 sides are the same, these 2 sides over here, and these 2 sides and these 2 sides are the same. So how many areas are we going to calculate for, guys? How many areas are we going to calculate? Who can tell me? How many sides to my shape do I have? How many surfaces do I have? Good. There will be 6 of them. Excellent. There are 6. So I'm going to find the area of this part and the area of this part. Oh, that's 2. And the area of this part and the area of that part, and the area of that part, and the area of that part. And I'm going to take all of them, add them together. So I'm going to go area of the first part plus area of the second part plus area of the third part plus area of the fourth, plus this is getting tired, plus area of the sixth, and all of them together are going to give me the total surface area. Okay, can I get a thumbs up, thumbs down? Do we understand how to calculate surface area? Excellent. Liam, is that a hand up or is that a thumbs up? Excellent, guys. Amazing. Now, if you guys aren't sure how to calculate for area, we did the calculations for area in the course that we did right before this one. So all of the videos on how to calculate area are on the website, and you guys can see exactly. Yes, that's the one. You guys can go see them on the website. You can go watch all of those lessons as we go. So Mila says, ma'am, can you explain again? I'm going to explain with the next example. Okay, so Mila. All right. Let's say here, if I unpack a cube, right? I have one side here, so Mila, and I have another side over here, and I have another side over here. But because it's a 3D shape, do I only have 3 sides? No. I also have 3 sides on the back. So if this is the top of my shape, oh, no, wrong color. Okay. If this is the top of my shape over here, there's also a bottom part to my shape. So there's the top and the bottom. And if this is the front of my shape over here, there's another side to my shape at the back, right? And if this is the right-hand side of my shape over here, there's also a left-hand side of my shape on this side over here. Okay. So when we have to look at this shape, we can't just say that my shape has 3 sides. It doesn't have 3 sides because if I have a top of a shape, I need to have a bottom. And if I have a front, I need to have a back. And if I have a side over here, I also need to have a side over here. And when I put it all together, it needs to give me 6 sides. Now, if I decide to unpack my box, I'm going to see that, okay, so if this middle part over here, if this middle part that we have over here, if this is the middle part of my box over here, if I fold it, if I fold my box, this is going to be the bottom part. And then this is going to be the back. This is going to be the back. So imagine that we're actually folding it into each other. And if this is the back, if this is the front, this is going to be the top of my box. Okay. What do you think these other ones over here? What do you think this one over here and this one is good and this one? What are they going to be, guys? Good, Liam. Excellent. Excellent. It's that easy. They're going to be the sides of my box. This is going to be the sides. Okay, the sides. So basically what I'm doing is I'm unpacking my box. Good. Titelo says side times side. Good, which is how we calculate the area of a square. You can also use length times breadth, but it's the same thing. Now, when I want to calculate for the area, what I then have to do is I have to calculate the area of this one, plus 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 this one. And when I calculate all the areas, I add them together, and that will give me total surface area. And Nokwezi, this is not the volume. It is not the volume. This is surface area. We are still calculating for area, but because we're calculating for the area of a 3D shape, we need to calculate the area of all the sides. Okay, Tyler, unfortunately, I can't go back, my sweetie. I cannot go back. Okay, I'm going to need you to, if you can, once this video is up, can I ask you to just watch the first part, because we're going to do something completely different now. Okay, don't stress. Okay, what you're talking about, Nokwezi, it's the volume. Okay, we're not thinking of the volume here. In this one, we're looking at the area still the area, but the area of every single surface. Okay. I need, again, a thumbs up, thumbs down. Are we okay with surface area? Excellent. Awesome, awesome. I'm getting so many thumbs up. So Mila's even like, love it. Awesome stuff. Landile's Gucci, love it. Awesome. All right. Okay. I think we're going to take a quick brain break before I introduce what we're going to do next, because I need you guys to be like, focus, focus, focus. Okay. Awesome. Oh, Lwandile, it's not country today. We're not doing country. I don't think we're going to be able to stomach country again, because we're just going to end up with AAs all over again. Albania, Nigeria, South Africa, and we're just going to end up Armenia, Angola, and we're going to end up with, no, we're not going to do that. Okay, we're going to play word chain again, and we're going to cut it short today, just for the interest of time. Okay. We're going to cut it short. 2 times, yes, Titelo, 100%, that's correct. But that's a very mathematical thing that you've put there, okay? And if you don't understand what any of those things mean, then it's gonna be very hard for you to understand how to interpret it. By the time you get to about grade 10, yes, you'll be able to interpret it. But for now, if you don't understand what it means, then that's gonna be very hard for you to understand. It's much easier for you to just be like, let me unpack my shape. How many sides do I have? How do I calculate the area of the side, end of the side, end of the side? Break them up, okay? You see, now Nokwezi's like, yo, is there a shorter way to do that? Yes, Nokwezi, yes, there is. Just unpack your box, your laptop box, and count the sides, okay? All right, guys, so our word for today is sport. Okay, now we want to do a word chain. We've got 5 minutes to do as many word chains as we can. Teacher Kat, do you want to start us off? Think of a sport.
Swimming.
Oh,
Because I
swimming. Funny, I just came back from a swimming gala before we started here. Okay, Tyler, if you're a bit stuck, watch what we're about to do. All right, so Teacher Kat said swimming. So that means that the next sport that we need to find needs to start with a G. No Kwezi?
I may have
What
just
sport?
ended. Oh, there you go.
No.
Golf.
Golf. All right, let's go with golf. Excellent. All right. So that means the next one that we need to start with is F. Thanks, Nokwezi. Thanks for that one. Lingomso, what do you think? Which one is next? What sport starts with an F? Lingomso? Oh no, I lost him. Hello. Angel, I didn't know fetch was a sport. Oh no. Okay, Ina, do you want to answer this one?
Football, man.
Oh yes, the superior sport, the sport of champions. Yes, football. Love it. Thank you, Ina. Lingomso, do you want to do L for me?
The football. This is L.
Yes, this is L now. Think of a sport that starts with L.
Oh,
nice one, Jiria. Oh, and Sam, nice. If you're stuck, look in the chat. Oh, long jump. All right, let's go with long jump. Long jump. Long jump. My teachers at school used to force me all the time to do long jump because I was tall and I sucked at it. I was so bad at it. I don't know why. They thought maybe the tallness meant that I could make it happen. I didn't make it happen. I didn't make it happen. Oh, Buliso, I love that one. Liabona, we need a sport that starts with a P, my sweetie. Hi, Liabona. Oh no, I lost you. You can unmute for me?
Powerlifting, ma'am.
Oh, powerlifting. Oh my goodness. Powerlifting. Sure, what a sport. Excellent. All right, nice one. Thanks, Liabona. Okay. The letter now, Tyler, is G. So I need Tingo. Do you want to tell me another sport that starts with a G? Oh, nice one, Bukang. I like that one. Tingo, do you want to unmute?
Gymnastics.
Oh, gymnastics. Nice one. Gymnastics. Well done. I like that one. Okay, now we need a sport that starts with S, guys. Jaria, I'm going to refuse soccer because we have football. Okay. And I know somebody's going to be like, no, but football is an American. No, it's not. No, it's not. No, it's not. The American one doesn't count. Don't tell the Americans I said that. No, Kwezi, what do you think? A sport that starts with S.
Shot put.
Shot put. Sure. Shot put. Okay, so we need a sport that starts with a T, and this is the last one we're going to take. Okay, thank you, Nokwezi. That was a very nice one. Titelo. Okay, maybe I'll take two more. I'll take Titelo and Khatliso, and then we'll be done. Titelo, give me a sport that starts with a T.
Tennis.
Ah, excellent. There we go. Tennis. Okay, somebody said turbo racing. Wow, okay, sure. Thank you, Titelo. All right, Khatliso, the last one, a sport that starts with S. Oh, Khatliso's gone. Oh no. Okay, I'll take the one in the chat. Everybody says softball, and I like it. I know. Tanwir, have you noticed? The last time we did it, we did countries, and we kept coming back to A. And today that we're doing sports, we keep coming back to S, like all the time. This thing is rigged. It's rigged somehow. I don't believe it. Okay. All right. Sure, guys. All right. So that's where we're going to stop for today with word chain. I want you guys to like think of all the different types of stuff you can think of about a topic. I'm not going to tell you what the topic is for next week. We're just going to pick it up from wherever you guys need to think of all these sports. Okay, everybody, let's take a quick shake, 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 shake. Shake. Hands up in the air. Up in the air. And wave them like you just don't care. Okay, I'm kidding. Yeah, all right. Okay, so we are going to be learning the names of 3D shapes. Okay, that's what we're going to be doing. sorry, Tenri. I didn't mean to make you turn to jelly. I just wanted you to get loose and ready to get into the maths. All right. Okay. What does anybody know? What is the name of this first shape that I have here? Excellent, Emerson. This is an easy one. Everybody will know this one. It's a cube. Okay, it's a cube. Oh no, I'm writing in the wrong color. Cube. Okay. Okay, this is a cube, right? But I don't want us to just think of this as a cube, okay? What I want us to do is we're going to break up this cube like we're unpacking a shape. And there are a lot of things that we need to know about the unpacking of a shape that makes this very important. So when we are looking at unpacking a shape, we need to think of all the faces, and faces is just like the surfaces. Remember, you were telling me that that rectangle has 6 surfaces. We don't call them surfaces, we call them faces. Okay, so I'm going to ask you guys in the chat again. How many faces does a cube have? Excellent, Bukam. Well done, guys. Good. It has 6 faces. Well done. 6 faces. Now, I need us to also count vertices. Okay. I know, it's a big word. It's a big word. I need you guys to remember it. Now, what a vertex actually is a corner. It's a corner. Excellent, Tanwir. Tanwir's done this before, I can tell. Okay, now, guys, if I go back to my book analogy, here's my book, right? Here's my book. If I count the corners of my book, I'm going to have 1 corner, 2, 3, 4, and then I'm going to turn it this way, 5, 6, and I turn it again, 7, 8. All right, good. We have 8 corners. Okay, or it's not 8 corners, we call it 8 vertices. Okay, I need my book again. My goodness. Tanweer is doing my job. I don't like this. Tanweer is doing my job. He's literally writing all the answers in the chat before I even ask the question. This is not fair, Tanweer. Hold on. Good. We've got 8 vertices. Okay, so I know my cube has 6 faces and it has 8 vertices. Now, the last thing we need to learn about, as Tanweer says, is the edges. Okay. Okay, Tanweer, okay, relax. Okay, now an edge is kind of like, you can think of it like an edge of a cliff. Okay, you can think of it as an edge of a cliff. If I have my book here, from here going down my book, this is an edge. Okay, and this over here, that's another edge. And then I go over here, from here going this way, that's another edge. And coming from the top here, going down like this, is another edge. So if I had to count how many edges I have on my book, which is kind of the same as a cube, how many edges am I going to have, guys? I can count them like this. I can go, there's an edge, 1, 2, there's another one, coming in from the back, 3, 4, 5, 6, 7, 8, 9. And if I look at my shape from the back over there, I'm going to have, there's another one, there's another one, there's another one. And I'm going to add them all up together and I'm going to get 12 edges. You guys are so smart. You guys are amazing. Awesome. I'm going to get 12 edges. Now, it's very important for us to remember all of these things. We need to remember, how many faces do I have? How many vertices do I have? I'm going to remove corner. Corner is something we use in grade 1. We don't use corner anymore. In grade 7, we use vertices. Good. The face, the vertices, and the edges. Now, what is this shape called? I know Tanweer already put it in the chat. Hopefully you guys didn't see it. Who knows what this shape is called? You can put it in the chat now, Tanweer. Good. It's a pyramid, but it's a very specific type of pyramid. Good, MSN. Amazing. All right, guys. We call it a square-based pyramid because at the bottom of my shape over here, at the bottom of my pyramid, what kind of shape do I have? Can you guys see it there at the bottom? It's a square. Good. So we call it a square-based pyramid. Excellent. A square-based pyramid. If I had a shape that looked like that, what kind of pyramid is this? Who knows? It's very easy. Just look at the bottom shape. What is this? Good. It's a triangle-based pyramid. Yeah, it's just a triangle-based pyramid. That's it. You guys got it. Okay. So we always look at the base and we look at what it looks like, and that's the kind of pyramid it is. Okay. Who can remind me, however, what do we call the top of my shape? What do we call this top part over here where everything meets? E. Who remembers? I want to see who remembers. It's not a vertex. Well, it is, but what is it exactly called? It's not called a point. Oh, Master Chaba and Tyler, yay, awesome. It's called an apex. Well done, an apex. There we go. You guys remembered. Or maybe you guys have learned it and I just didn't know. And now I think, yo, you guys are geniuses. That time you learned it at school. Okay, good. It's called an apex at the top. Now, again, we need to think about how many faces does my square-based pyramid have? How many faces, guys? Let's count. I've got 1, there's my square, and then I've got 2, 3, and how many do I have at the back there? I'm gonna have 4 and 5, good. So my shape has 5 faces. Okay. How many vertices? How many corners do I have? There, I've got 1 corner, 2, 3, 4, 5. I've still got 5 vertices. Good. So this is 5. How many edges do I have? Let's count edges, guys. Let's see. Here's 1, 1, 2, 3, 4. Here's 1, 5, 6, 7. And I'm going to have 1 for the shape, for the 2 shapes there at the back, and that will make 8. 8 of them. Okay. Sure. Okay. I don't think I really need to teach this. You guys are just excellent. You guys are excellent. Yes, Tenwir, please don't tell Watobe that you're going to take my job. They won't pay me. Don't. But you're doing a fantastic job. Okay. Let's think about this shape over here. What is this shape called? I think somebody already put it in the chat before. What is this shape over here? What is it called, guys? Tyler says, a soup cup. No, my sweetie. It's not a soup cup. It's a sphere, but Keisha, it's not a full sphere. Sam, excellent. It's half a sphere. And when we look at half a sphere, we call it a hemisphere. Okay. It's called a hemisphere. Okay. Half sphere, hemisphere. Okay. Not a soup cup. Okay, let's think about this. We need to find out how many faces a hemisphere has, how many vertices, and how many edges. Edges. Yeah. Okay, how many faces do I have, guys? I don't think it's 1. Here's 1 of them, yes. Somebody said, ma'am, can you please scroll down so that I can write it down? Okay, Masichaba, in just a second. Okay, I just want us to think of this. And I now see some of you saying 2. Who can explain to me why 2? Teacher Kat, what do you think? This one is a bit of a tricky one.
I mean, it's the one on top.
Mm-hmm.
And it's our little cup at the bottom. That's 2.
Yeah, exactly. So there's the flat face and then there's the round face. Like, for instance, if I had a round lid, like this, right? Here's my round lid. Here's my flat face. This whole part here is my flat face. And this bottom, my round face. And this bottom part over here is my flat face, that part there. Okay, I have 2 faces, right? Now, if I have 2 faces, how many vertices do I have, guys? How many corners do I have? Yo, Titelo's like 1, Mpo's like 0, and then Titelo's like, or 2. Guys, what's the actual answer? Goodness says none. And I agree with goodness because there are no sharp edges. There are no like corners. There's no corner, right? There's no corner. So there's 0 vertices. How many edges do I have? How many edges do I have, guys? This is a tough one. Okay, so if I draw my edge, let me cancel all the stuff out here. Like, if I draw my edge over here, right? This whole thing is already part of my edge. The whole thing going around is 1 edge. So how many edges do I actually have, guys? 1. I have exactly 1 edge. I have 1. 1. Good. I have 1 edge. Just 1. Okay. Excellent. All right. Okay, I think we're going to stop it there.